In this problem, we let z be a complex number satisfying 12 times the modulus of z squared equals to 2 times the modulus of z plus 2 squared plus the modulus of z squared plus 1 squared plus 31. What is the value of z plus 6 over z? First of all, to solve this problem, we must understand the definition of a modulus. If you have a complex number z equals to a plus bi, then we have the modulus of z equals to a squared plus b squared square root. And we also know that the modulus squared equals to the product of z times the complex conjugate of z, which would be a minus bi. So with this in mind, the equation can be rewritten as 12 times z times the conjugate of z equals to 2 times z plus 2 times the conjugate of z plus 2 plus z squared plus 1 times the conjugate of z squared plus 1 and plus 31. And then expanding this will give us negative 12 times z times conjugate of z plus 2z times conjugate of z plus 4z plus conjugate of z plus 8 plus z squared times the conjugate of z squared, the conjugate of z squared plus z squared plus the conjugate of z squared plus 32 equals to 0. So, after simplification, we will have z squared plus 2z times conjugate of z plus the conjugate of z squared plus 4 times z plus conjugate of z plus 4 plus z squared times the conjugate of z squared minus 12 times z times conjugate of z plus 36 equal to 0. So then, the product of this would be, this can be rewritten in the form of the sum of two perfect squares. In this case, z plus conjugate of z minus plus 2, and then minus 6, plus 2 squared, plus z times conjugate of z minus 6 squared equals to 0. And then we know that since the two quantities in the parentheses are real, both quantities must equal to 0, meaning that this portion and this portion must both equal to 0. So at the end, we can get that z plus 6 over z will equal to z plus the conjugate of z, which will equal to negative 2. And that's the answer to this problem.